my desktop. The language from the language selector, you can download JVM. I'm going to type in main, which will help IntelliJ IDEA suggest a template for you, which is a runnable application. So once you type in main and hit enter, or main control space and enter, you'll get this little template for a runnable Kotlin application. So this is now runnable. So if you right click ground, and I'm going to make it an object. So scroll all the way down and select object here. You can hit create, and this is going to open up in a snap. And this project is a plain IntelliJ project for Kotlin, obviously. The build system is not really all that important, but I'm going to select Maven here. And the JDK should have an option here in the dropdown if you have a JDK already. If you don't, you can go add a JDK and point to the path where you've just downloaded the Oracle JDK from the Oracle homepage. So make sure you have a JDK here in the dropdown. I think you can also set IntelliJ to download a JDK for you if in IntelliJ project for Kotlin. We're going to spend all of our time in this mini-series to make here in IntelliJ say print line, so print ln. Welcome back to Kotlin. Application for now just prints out something. And this thing is a runnable application. If we run it, we print this little string to the console here in IntelliJ IDEA. So we have this let's rock, which should get us ready to write some code in this video. Now, for every video in this mini-series, I'm going to create a standalone application so that we have the code nice and clean. So here under com.rock.jvm, I'm going to create a new Kotlin class/file. I'm going to call this basics. And I'm going to make it an object, and we're going to explore what an object is in Kotlin in one of the next videos where we are going to discuss object-oriented principles in Kotlin. For now, just make an object. I'm going to call this basics and type in main here in IntelliJ, which will autocomplete to this little definition, JVM static fun main with args as an array of string. This is an entry point to a JVM application. This is essentially what turns this object into a standalone application. So obviously, if we print line basics or something like that, this is a standalone application, much like the playground application was a little bit earlier that I showed you like a minute ago. So we have this little string, and here I'm going to start exploring some of the essential features of the Kotlin language. Now, the first thing that I'm going to start with is obviously defining values and variables. Without them, there is no programming. So let me define some values. The value definition in Kotlin is done with a keyword val, V-A-L. And I'm going to define my first value. I'm going to call this meaning of life, having the type int, and on the right-hand side, I'm going to say its value is 42. So this is a value definition. This is the syntax on how to do it. Keyword val, the name of the value. Then we have int, which is the type of this value. Kotlin is a statically typed language in which the compiler knows at all times the types of every expression and of every value and variable in the code. So the compiler has to know that this meaning of life must be an int. And on the right-hand side of this assignment operator, we have the value 42. If you've done any sort of programming in other languages, values are essentially constants. So for example, I could say const int meaning of life equals 42. This would be an equivalent C-like syntax. For example, in C or C# or C++ or Java or TypeScript, this would be some equivalent definition. In this case, it means that I cannot change the value of meaning of life. So if I say meaning of life equals 43 for whatever reason, this is illegal, so not okay. You cannot change the value of a valid definition. So this means that values are what is called immutable. You cannot change them. So this is an error in Kotlin. At the same time, values can be defined without the typed annotation here. So I can define val meaning of life version 2. Just say equals 42, and the compiler will automatically know that this thing is an int just by judging the value of the expression or the type of the expression on the right-hand side of the assignment. So the compiler knows that 42 is an int, and therefore it will attach the type int to meaning of life version 2. We call this type inference. This is a powerful feature of the Kotlin compiler that allows it to figure out the types of things without us having to explicitly mention the types everywhere. So this makes the life of Kotlin programmers far easier because we don't have to type in all the types manually all the time. So by this point, you already know a couple of things about Kotlin. You know how to define values, the fact that this cannot be changed, and this type inference feature, which makes the life of Kotlin programmers a little bit easier. There's also the notion of a variable that is a changeable piece of data. So you can define this as a var, V-A-R. I'm going to call this objective in life, which we all know can change. And you can follow the same rules as for vals. So for example, I can say objective in life is equal to 32, and the compiler figures out that objective in life is an integer, as IntelliJ will also tell you. And you can also add types if you want manually. Now, the difference between val and var is that variables can be changed. So for example, I can say objective in life is equal to 45, and this is okay. Vars can be changed. As for the standard types that you can use in Kotlin, they are very similar to other types that you can see from other languages. For example, you have int, boolean, char, short, long, float, double, all of them with a capital letter, which correspond to the equivalent in Java or in C or things of that sort. You've probably seen this before. So int is a numerical, boolean is true or false, char is a simple character, short is an integer with just 2 bytes instead of 4, long is with 8 bytes instead of 4, float and double are decimals, float is 4 bytes and double is 8 bytes each. Not really necessary to remember all of these representations, just know that these types are available in Kotlin much like they are in most other mainstream languages. Now, a very important data type in Kotlin is the string type, because manipulating text is a big thing in programming in general, so strings are also big in Kotlin, much like in other JVM languages. So let me define a string as the string with the double quotes. Let's say I love Kotlin. And be very careful about quotes in Kotlin. In Kotlin, we have strings delimited by double quotes, not by single quotes. So if I define, let's call this LL or string or something like that, some string, this is illegal. So unlike Python and JavaScript, for example, where it's legal to write a string in between single quotes, in Kotlin, that's not the case. We define characters in between single quotes. So by virtue of the Kotlin compiler, you can only write a single character. In between single quotes. So this is a character, and the one above is a string because it's delimited by double quotes. So be very careful with that, especially if you're coming from Python or JavaScript. And in Kotlin, much like other languages, we have combinations of strings. So let's call this a combined string as I plus a space plus love plus another space plus Kotlin. And what this does is just concatenates all these strings into one giant string. So the plus operator on string just concatenates these strings. You also have the notion of a template in Kotlin. So let's call this a template as, let's say, the meaning of life is, and then you can inject the value of one of the variables that you defined before or any sort of expression by using the $sign. So I can say $meaning of life, and the value of meaning of life is injected here into the string. This is a very handy feature that you can find in Kotlin. So these are values, variables, types, some standard types, including the string type, which has all the general string manipulators that you see in other languages. Let's talk about expressions. So expressions are structures that can be reduced to a value. You've seen this before in other languages. For example, an expression is equal to 2 plus 3. And obviously, this is an expression that returns an int, and the compiler can figure that out and associate the type int to this value, an expression, which is known to be an int, just by looking at the type of the expression on the right-hand side. Now, why am I talking about expressions? Well, expressions are any sort of structure that can be evaluated to a value, and in Kotlin specifically, we have some structures, for example, the if and when structures, that have multiple meanings. Let me show you what I mean. So generally, let me define val a condition as 1 bigger than 2. So this is a Boolean expression, and this returns true or false, and the compiler can figure out the type of this expression. So this is a Boolean. So in Kotlin, for example, if you want to write an if condition, so if a condition, you can open some curly braces and you can do something like print line, the condition is true, else open some curly braces and you can print line, the condition is false. So you've probably seen this sort of structure before. It looks pretty much the same in most languages. But in Kotlin, if structures can be expressions in the sense that the entire structure can evaluate to a value. Let me show you what I mean. So I'm going to say val an if expression as, so notice that I'm using the assignment operator, and on the right-hand side, I'm going to write an expression. So I'm going to say if a condition, then I'm going to return, or I'm going to say 42, else 999, or something like that. And this whole thing is now not an instruction, meaning that we tell the computer what to do, but rather we say that this entire expression evaluates to either 42 or 999, depending on what a condition is. So this is an expression. And this, because it's expression, it can be assigned to a value. And this an if expression takes the value of 999 because a condition is false. And you can test that out by printing an if expression. So the last thing that this application is going to print is the number 999 because the condition was false. So this entire thing evaluates to something. This is very, very important. Likewise, Kotlin has some kind of, let's call this switch on steroids, which are the when expressions. So when expressions are more complex expressions where you can test the equality or some conditions multiple at the time. So for example, I can say when meaning of life, and this is the syntax. So when meaning of life, much like if a condition, when meaning of life, and then here inside the curly braces, you can test the values or the possible values of meaning of life. For example, 42. If so, you'll do something like print line, the meaning of life from the Hitchhiker's Guide to the Galaxy. When it's 43, let's say print line, maybe not the meaning of life, but quite close. Otherwise, in the default case or the case that doesn't match anything else, we say it's else, and then we print line something else. So when meaning of life is 42, then we do something. If meaning of life is 43, then we print something else. Otherwise, we do something else. And you can chain as many conditions as you want. They're all tested in sequence. So this entire structure here looks like a switch in C or in Java. But it can also be used as an expression in which all these branches after the thin arrows here can return a value. So the when expression or when structure becomes a when expression. That is, if the branches here on the right hand side return something. For example, I can say val, let's call this meaning of life message, as. And because I define a val here, what follows is an expression. So I'm going to say when meaning of life. And here, in case it's 42, let's say we're returning HGG from Hitchhiker's Guide to the Galaxy. If it's 43, then quite close. And else, something else. Now, this entire structure is evaluates to a value, either HGG, quite close, or something else, depending on the value of meaning of life. So the mental difference between the first when structure and the second one is that in the first one, we instruct the computer to do something. We call that an instruction. While in the second case, this when structure evaluates to a value. So that it becomes an expression. So be careful of the difference. Much like an if structure, a when structure can be either an instruction or an expression depending on whether it can be evaluated to a value or not. Okay, so we have if structures, we have when structures. Let's talk about looping. This is one of the most important things that we ever do in programming, and looping is no exception here for Kotlin. So I'm going to show you various ways that you can do looping. For example, let's count from 1 to 10. This is one of the classical examples of looping. So I'm going to print something just so that we can isolate the content in the console when we run the application. Let's call this inclusive range, which is 1 to 10, let's say. And we're going to write a for loop. So I'm going to say for. And in parentheses, I'm going to say a counter, let's call this I, in 1 dot dot 10. So in between 1 and 10, and notice that the IDE has added these little markers here just so that we can know that this is an inclusive range from 1 to 10 inclusively. And you can open some curly braces and do whatever you want with the counter I. And the classical thing that we can do is print line I. So if we run this application, we're going to see all the numbers from 1 to 10, each being printed on one line. So we have all the numbers 1 through 10 being printed one at a time. So this is how we can do looping. And there are various ranges between 1 and 10. And in the second case, this when structure evaluates to a value. So that it becomes an expression. So be careful of the difference. Much like an if structure, a when structure can be either an instruction or an expression depending. There's no exception here for Kotlin. So I'm going to show you various ways that you can do looping. For example, let's count from 1 to 10. This is one of the classical examples of looping. So I'm going to print something just so that we can isolate the content in the console when we run the application. Let's call this inclusive range, which is 1 to 10, let's say. And we're going to write a for loop. So I'm going to say for. And in parentheses, I'm going to say a counter, let's call this I, in 1 dot dot 10. So in between 1 and 10, and notice that the ID has added these little markers here just so that we can know that this is an inclusive range from 1 to 10 inclusively. And you can open some curly braces and do whatever you want with the counter I. And the classical thing that we can do is print line I. So if we run this application, we're going to see all the numbers from 1 to 10, each being printed on one line. So we have all the numbers 1 through 10 being printed one at a time. So this is how we can do looping. And there are various ranges that you can iterate upon. For example, you can say ranges. So we have 1 to 10, that's inclusive. Then we have 1 dot dot less than 10, which is exclusive. So from 1 to 10 without using 10. We also have 1 until 10, which is the same thing, the same as the exclusive range. And we also have various other variations. For example, 1 dot dot 10 step 2, which counts from 1 to 10 in steps of 2. So that's 1, 3, 5, 7, and 9. So that's going to be this range. And you can also count descendingly, for example, 10 down to 1. So this is an inclusive range counting backwards from 10 to 1. So there are various kinds of ranges that you can test. If you want, you can change this range to either one of these versions and you'll see the effect. Let's talk about arrays or lists. So I'm going to print line a little section here so that we can isolate the output. So let's say iterating over a collection. So I'm going to define a val, I'm going to call this a list, as list of, and here you can chain any sort of elements that you like. For example, 1, 5, 3, 2, 4. So this is going to be a list of these items in this exact order. Or you can say a array of 1, 5, 3, 2, 4, and this creates an array instead of a list. And these collections are different fundamentally. We're going to talk about them in a later video in this series, so don't worry about that. Just use the lists, for example. And if you want to iterate over this collection, you can say for, let's call this element in a list. So this is how we can iterate over all the elements in this list in sequence. You can print it out in one at a time. So I'm going to say element. And if we run this application, we're going to see the numbers 1, 5, 3, 2, 4 being printed exactly in the order that they were defined or inserted into the list. So this is how we can iterate over the collection. We can say for elements in the collection that we want to iterate on. So these are for loops. We have for loops with ranges, and we have for loops with collections. Okay, let's talk about while loops. And while loops are also quite popular when you don't necessarily want to iterate over a collection, for instance. Maybe you want to keep on doing something while a condition is true. So I'm going to say print line while loops. And the equivalent way of iterating over a collection would be to say var I equals 1 and while I is less than or equal to 10. And inside you're going to print line I, and you're going to do I plus equals 1, which is I is equal to I plus 1. You've done this sort of reassignment before. So I'm going to say I plus equals 1, which reassigns I to the old version of I plus 1. So this is the equivalent of the for loop that we said before, from 1 to 10, where we take a little bit more care to increment this little counter, because if we don't, then we're going to get into an infinite loop. But while loops are a little bit more general than a for loop, in the sense that you can keep on doing the same thing until a condition becomes false. And obviously, if you run this application, this thing will do exactly as you expect. So we have a counter from 1 to 10. There's also a do while loop, in which the instructions that you set inside the while loop are executed before the condition is being tested. So this is a version of a do while loop. So I'm going to say do. I'm going to have print line I, and then I'm going to say I minus equals 1, while I is bigger than 0, for instance. So I'm counting backwards. I'm going to say print line counting backwards with do while. Now, do whiles are a little bit more rarely used, but they're still quite available in Kotlin. So we have I becomes 11 at the end of the previous while loop, because that broke the while loop, which is correct. And then we have 11, 10 all the way down to 1. So do whiles are reminiscent of the C family of languages, in which we have of the same sort of structure. And by the way, I added a semicolon here out of reflex, but semicolons are not count as an int, and this function returns a string. So notice the syntax here. Fun, name of the function, an argument list of the form name colon type. All the arguments or parameters are separated by comma. And finally, at the end of the function, we specify the return type. And then we open some curly braces, and then we write our code. So for example, here I'm going to write a function that concatenates this string this amount of times. So I'm going to define a var, let's call this result, starting at the empty string, and I'm going to run a for loop for a count in one ... count. I'm going to say result plus equals a string. So I'm going to attach or concatenate the string to the result string as many times as the count number suggests or says. And finally, at the end of the function, I'm going to say return. So I'm going to use the return keyword result. This is a very similar structure to other programming languages, so the concept of a function shouldn't really be all that foreign for you. Now, in Kotlin, there is a special syntax for functions that evaluate to a single expression. So single expression function syntax is a very similar thing like fun, let's call this combined strings, that takes a string A as a string and string B as a string. And let's assume that we return a string which is the combination of these two with a little format in between. So normally we would say return, and then I would say $string A dash 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 string B for whatever reason. So this thing is a single expression. And instead of opening and closing some curly braces with the return keyword, I'm going to say equals, and I'm going to cut the return keyword and just keep the expression. So the equivalent syntax is this thing with equals, and then the implementation is one expression. Now, all these functions return a meaningful value. So notice that they have colon string, and the type can sometimes be omitted, especially for single expression functions. That is because the compiler can figure out the type of the expression that you use to implement the function. And so the compiler already knows that combined strings returns a string just by looking at the expression on the right-hand side of equals. All right. Now, specifically for functions that don't return any meaningful value, they return a thing called unit. Unit means void in other languages. So for example, in languages like Java or C, we could say void do something, or function returning void that takes an argument as a string. So this would be the equivalent Java syntax. In Kotlin, we would say a fun, let's call this function returning void with an arg which is of type string. So notice that the syntax here is swapped a bit. And we say that this thing returns unit. And here, you don't really have to return anything. So you can say print line, this is a string. And I'm going to inject the arg inside. So notice that the return type is unit, and you may omit this because if you don't return anything, the compiler will figure out that the function does return unit. And unit is equivalent to void in other languages if you want to make the connection to that concept. All right, so in just about 20 minutes, you got the basics of Kotlin. Here, you don't really have to return anything. So you can say print line, this is a string. And I'm going to inject the arg inside. So notice that the return type is unit, and you may omit this because if you don't return anything, the compiler will figure out that the function does return unit. And unit is equivalent to void in other languages if you want to make the connection to that concept. All right, so in just about 20 minutes, you got the languages. So we have the concept of welcome back. Hey everyone, and welcome back to Kotlin. For C, we could say void. The syntax here is swapped a bit. And we say that this thing returns unit. And here, you don't really have to return anything. So you can say print line, this is a string. And I'm going to inject the arg. The compiler will figure out has the type pet, and therefore, because the type pet has the environment and the software and tools that you need to get started. In the previous part, we ran through the basics of Kotlin, including values, variables, types, type inference, regular types, strings, instructions, expressions, and looping in Kotlin. So if you haven't checked out that part, I recommend that you do that now before we continue. In this video, we're going to go through the object-oriented features of Kotlin. So under the com.rock.jvm package of the Kotlin at Lightspeed project, I'm going to create a new standalone application. I'm going to call this OOP. And I make a standalone application